Hi everyone, this is Kiranmay from H&S department. Today we are in this session we are going to discuss about Unit 5 dielectric and magnetic properties. Under the magnetic properties we are going to discuss about the different types of magnetic materials and also the differentiation between them. Coming to the magnetic materials, these are the materials which get magnetized when we place them in the external magnetic field. So the substance develop magnetization which may be parallel or anti-parallel to the applied field depending upon the magnitude and sign of response of the applied field, and also on the basis of temperature. All the materials got classified into 5 different magnetic materials: diamagnetic, paramagnetic, ferromagnetic, antiferro, and ferrimagnetic materials. The materials which are lack of permanent dipoles, whatever the magnetic material we had chosen, if it is lack of permanent magnetic dipoles, then the materials are called as diamagnetic. If not, if the atoms of the material carry magnetic dipoles and they does not interact with each other, then then the materials are called as paramagnetic. If the atoms of the material carry magnetic dipoles, they interact with each other, line up themselves parallel to each other, then the material are called ferromagnetic. If the atoms of the material carry permanent dipoles, interact with each other, line up themselves antiparallel with equal magnitude, then the material is antiferromagnetic. In the same way, if the atoms of the material carry permanent dipoles, interact with each other, line up themselves parallel to each other with unequal magnitude, then the material is called as ferrimagnetic materials. First of all, a diamagnetic material. The substance which when placed in magnetic field acquire feeble magnetization opposite to the direction of the field are known as diamagnetic materials. Example: bismuth, zinc, copper, argon, gold, and so. Coming to the properties of diamagnetic material, this diamagnetism occurs only in the materials which are lack of permanent dipoles. Now, when you place such diamagnetic material in a external magnetic field, then the bar diamagnet will arrange itself perpendicular to the field direction. That is, the longest axis of the material will become perpendicular to the field direction. The permeability of these materials is less than 1 and susceptibility is greater than susceptibility is negative value, and permeability value is less than 1. Now, when YouTube containing diamagnetic material is placed in magnetic field, then it shows depression in the curve. When a diamagnetic material is placed in non-uniform field, then it tends to move from stronger part to weaker part of the field. Magnetic lines of force does not prefer to pass through the diamagnetic substances. And the susceptibility of diamagnetic materials is independent of temperature, and the best example for them is organic materials. Coming to the paramagnetic material, these are the substances which when placed in magnetic field acquire feeble magnetism in the direction of magnetic field, known as paramagnetic. Example: aluminum, platinum, manganese, oxygen, and so. Now, when the paramagnetic magnetism occurs in those materials in which permanent dipoles exist and possess net magnetic moment. When a bar magnet of paramagnetic substance is suspended freely between two magnetic dipoles, its axis becomes parallel to the magnetic field. When paramagnetic substance is placed in magnetic field, it tries to concentrate the lines of force to pass through it, whereas the permeability value is greater than 1 and the susceptibility value is small and positive. When YouTube containing permanent paramagnetic liquid is placed in a magnetic field, then it shows a rise elevation on the top of the liquid. And the paramagnetic substance which is placed in non-uniform magnetic field, it tends to move from weaker part of the field to stronger part of the field. Such a stronger part of the field and the susceptibility of paramagnetic materials depends on temperature and follows Curie's law, Xi proportional to 1 by T. So as the temperature increases, susceptibility goes on decreasing. The best example for these materials is alkali metals. Then comes to the third magnetic material, that is ferromagnetic material, the substance which when placed in magnetic field becomes strongly magnetized in the direction of field, known as ferromagnetic materials, and the examples are iron, nickel, cobalt, and so ferromagnetic materials occurs in those materials in which atoms have permanent dipoles and possess net magnetic moment. When a bar of ferromagnetic substance is placed freely in two magnetic dipoles, its axis becomes parallel to the magnetic field, and also it concentrates the field lines to pass through it, uh, where the density is more. The permeability is much greater than 1 and the susceptibility is high and positive. And the same way, when you take a ferromagnetic liquid in a tube and placed in an external magnetic field, then it shows a rise or elevation as of a paramagnetic liquid. So when a ferromagnetic substance is placed in non-uniform field, then it tends to move from weaker to longer path. Susceptibility of ferromagnetic materials depends on temperature. The rare earth metals are the best examples for the ferromagnetic materials. Coming to the antiferromagnetic materials, this magnetism occurs in those materials in which atoms are very close to each other and possess permanent magnetic dipoles. Due to antiparallel equal magnetic spins, the magnetic effect is zero. Electron spins of atoms are aligned and antiparallel with equal magnitude. Magnetic permeability is positive and very high. Magnetic susceptibility is positive and very small. Susceptibility depends on temperature, and examples for antiferro are salts of transition elements. Coming to the ferrimagnetic materials, these are the magnetic materials in those in which it possesses permanent magnetic dipoles. Due to parallel equal magnitude spins, the resultant magnetic effect is along the direction of the applied field, and the electron spins of atoms are aligned antiparallel with unequal magnitude, and magnetic permeability is positive and very high. Susceptibility is positive and very large. Hence, the susceptibility depends on temperature, and the best examples are ferrites. Here on the screen, you can observe certain differentiations between the 5 different magnetic materials: diamagnetic, paramagnetic, ferro, antiferro, and ferrimagnetic materials. Thank you.